I hope the slides are visible
Yes, ma'am.
Yes, it is.
Yes.
and voice is also clear.
Yes, ma'am.
Okay, okay. So, hello everyone. I know it's afternoon time and very difficult to listen to anybody. So, I will try my best efforts to not let you sleep. So, today we are going to discuss the data science applications for the mathematicians. So, since data science cannot exist without the mathematicians, so we will start with the introduction of the big data, then big data analytics, then what is data science and who is a data scientist. Since we are talking about the data scientist these days, so data scientist and data science, they have become a buzzword. So it's important to understand what do they do and what are the kind of tasks they are doing in the this IT industry. Then we are going to discuss the various data science applications, and we are going to discuss two applications in detail, that is recommender system and the data science project using the Python. Then it will be followed by summary and the references. So to begin with, let us understand, because we are discussing about, and the title of the workshop is also about the mathematical foundations of the data science. So what is data? And I request everyone to participate, because without that it will be difficult to proceed further and it will not be possible for you also to listen, right? So what is data? We are always using this term data everywhere. So you may unmute yourself and you may share your opinion. I'm not looking forward to any technical definition, just because every time we are talking about data. So how do we define data in the layman terms? Yes, please. So you may unmute, because I'll have to uh, get out of this mode to read the messages. You can please speak up. That will be help us and others also in making the session more interactive. No? What is data?
Numerical figure or information about some value or things.
Can you just repeat?
Numerical figures or some values related with the things.
The numerical figures and the information.
Yep.
Anybody else?
Ma'am, raw facts and figures.
Yeah, exactly. See, we can, when we are defining the data, we cannot say it is the information. So data is when we are talking about anything that is coming up, raw facts and figures. Like when we say we have the alphabets, we have the numeric values, they, if they are not carrying any meaning, because when we have the alphabets, the like A, B, C, D, so we don't have any meaning for that. They are just the facts and figures. So when we rearrange these alphabets, we get a word, we get a sentence, right? So similarly, whatever is, see, like this session is being recorded, right? So this is data that is being generated. We have mobile phones, we have multiple sensors in these mobile phones, we have numerous applications which are running in these mobile phones, right? So we are talking about various web applications which are there, right? So everywhere the data is coming up. We are talking about the satellites, right? Satellites, the lot of data is being generated by these satellites from the various kinds of observations, right? So whatever is happening around us, so each and every activity is generating the data, and this data is basically, we, if technically we define, these are the raw facts and figures, like numbers, words, measurements, observations, or just the descriptions of the things, or anything like that, right? So we cannot define data using the information, because we data, when we process this particular data, so data is being processed to derive the information or the knowledge, right? So for getting the information or the knowledge, we apply certain techniques. Only then we get the information or the knowledge from the data. Otherwise, data is not information. It is just the raw facts and the figures that are coming up through any kind of activities which are going around us, right? So whatever task we are doing, so data is being generated. Then when we are talking, see, these days we are talking about the big data. So what is the difference when we are talking about, so see, we were having for like for the you can say for throughout the decades, last decades, any of the decades you talk about, we were always having the data. And in the last 10 years or last 50 years also, we had the data. But we are talking about this data more these days as compared to the previous years. So why we are talking? So what is the difference between, let us say, if we talk about what was the kind of data that we had the 10 years back or the 20 years back, and we are talking about the data that has been generated in the last 2 3 years, or let us say the last 5 years. So what do you think? What is the difference between the data? Anybody, please? So what is the difference in the data that we are talking about that we have today and that we had in the past? So see, when we were talking about the data in the past, that was small in size, that was structured, that had a single format. So that for that small size data, the basic statistical techniques we used to were used to process this particular data, and we were able to derive the insights from that particular data. The whole data that we used to have in the past, that was structured, that had only one format. That means more or less the data was in the structured format, that is the, we can say, in the form of rows and columns we used to store that particular data. So that was the single format, we can say, the way data was available in the past. So all the techniques which are available, that maybe the data storage techniques, like the database management systems we have, so they were, you can say, they were designed and developed in order to process that particular kind of data only, because that was the, we say, necessary, necessity is the mother of invention. So that in that particular era, let's say in the last 50 years, so all the all the techniques or the technologies or the tools, they were designed to handle such kind of data that was in a structured format and that had a single format. But now when we are talking about data in the current scenario that we have, that the data that we have today, that is large in size. How large? Beyond, you can say, beyond imagination, we can say, because we cannot measure the size of this particular data. Nobody can tell what is the size of data that is available in the present. Then this data is not having a single format. It is having the multiple formats. It is semi-structured, it is unstructured. Since the size has changed from the small size to the large size, from the structured to the semi-structured or the unstructured, then from the single format to the multiple formats. So the existing techniques that we have, they cannot be used to handle such kind of data. Neither the storage techniques, nor the algorithms which are available, and nor the other tools and techniques which are available, they cannot be used to process this kind of data. So again, we have a need. So different kinds of technologies to be developed. So because the data has changed over a period of time. Can anybody tell me what was the major reason for the development of this particular data? What was the major breakthrough due to which the data has escalated or the data has become big data? Anybody? What was the major breakthrough that led this data to be the big data?
Method of collection of these data, as because nowadays we are more dependent on the digital data.
Yes, digitization, right? So one factor is digitization. Another one is, what was the other one? So that was the basically the major. It's no, digitization is not the major breakthrough that came later on, but the major first breakthrough that was there, because which led to the huge amount of data. Yes, please. Anybody? We all know this. I'm sure you all know this.
Social media.
Yeah, it's a social media. See, it was in the 1990s, right, when this World Wide Web came into existence. With the inception of the World Wide Web and the revolution of the world, you can say, when the Web 2.0 that was born, you can say, that was developed, or you can say that were designed, the social media applications, when they came into existence. So during that era, these social media applications, they led to the revolution over the web. And since because before that in the web 1.0, only the few companies used to generate the data. So the size of data that was limited at that particular period of time, because how much data the companies will be generating. But with the revolution of the World Wide Web 2.0, all the social media applications, they came into the existence. And since each and every user, right, so they all of us, see, all of us are using the social media applications, and we all became the generators of the data. So we all are the consumers of the data, and we are also the producers of the data, right? Since how much is the size of the population? We know. And 60%, 63, according to the studies, 63% of the world population is online. And can you tell me, see, if we just check out how many accounts we all have on the, or you can say on the social media applications. According to the studies, every user is having at least 7 to 9 social media accounts online. So one account means how much data? Right? Because it's just not about our profile information. If you have an account on the Instagram, you are every day uploading so many pictures of yours. So in the last 2 years, so many businesses have flourished, and they are only using the Instagram for doing their business, and they are generating huge amount of data. You talk about the YouTube, we are millions of you can say number of videos are being uploaded over there, right? So everywhere we say, so all the users are generating huge amount of data. And we all know that if we talk about the Gmail, each of us is having at least 2 to 3 Gmail accounts. So that means we have so much of data online, right? So this is all we say, this is how the big data is being generated. Now along with that, we are talking about the digitization of each and every application that we do, whatever task we are talking about, everything is getting digitized. So it is all leading to the huge amount of data. So in order to understand this particular big data, you can say the scientists, they have designed certain V's, which we call them as the volume, velocity, variety, and veracity. Since for designing the technologies, for there may be the algorithms for processing the data, or they may be the how to store this particular data. So in order to for the better understanding of this data, these V's were given. So let us understand what does it mean. So volume means amount of data that we have. See, as I said, 63% of the world's population is online. So we can understand the amount of data they all are generating. And every day, we are generating 2.5 quintillion bytes of data. So that contributes to the volume of the data. And this volume of data, that is increasing in 2 dimensions. One is, you can say, the number of rows, and another is the number of dimensions. So when we are talking about the number of dimensions, so depending upon the application, these days we are talking about, see, when we are talking about applying the deep learning algorithms, and we are talking about the image analytics. So if we are talking about high resolution images, and if we take just the one image of resolution 1024 by 1024, that contributes to around 10 to the power 6 features of that particular image. So that these 10 raised to the power 6 features, they are basically the dimensions, which you can say when we have to handle such kind of dimensions, then we know what all algorithms are required, then the computational power that is required, and that too, not just a single image. We are talking about working on training the models on the billions of images. So that is about the complexity of the data that is being increasing due to the size of data, not in terms of just the bytes of data that is being increasing, but also in terms of the number of dimensions which are contributing towards the complexity of the data. And according to the studies, we say we are living in a data age. That is the global data sphere we are talking about. You can see over here, so the amount of data that we are expecting that is going to increase from 2010, that was the data was merely 2 to 4 zettabytes, and in the last 10 to 12 years we can see how the data is growing. It is almost doubling or more than double, you can see, and it is expected that by 2025 this is going to be around 175 zettabytes of data. So we need to be prepared for handling this amount of data. So and we don't know so you need to develop the new technologies, you need to develop the new algorithms for processing all such amount of data that is being generated. Then we talk about the velocity. Velocity means the speed with which the data is growing. So what every year Domo gives one, you can say, all these statistics, right? So it is the you can say this is the 10th version of the statistics that data never sleeps. So that means 24/7 data is being generated. And here you can see, so how much data is generated just in the 60 seconds. Twitter is on the Twitter, people are tweeting 347,000 tweets per minute. You see on the Google, 5.9 million searches are performed within the 60 seconds, right? 60,000 photos are being uploaded on the Instagram. 1.7 million pieces of content is being generated on the Facebook, and 500 hours of videos is being uploaded on the YouTube every minute. So if this much of amount of data is being generated within a minute, you can understand the amount of data that is being generated in 24/7. So, and the speed with which, since we say that the velocity, the speed with which the data is growing, it is very fast. So we need to devise the techniques to handle the new opportunities which are coming up. If you are not able to handle the opportunities, you have lost the business, right? So this is how, so we are talking about these days the real time analytics, how we can handle the demands of the users, understand the behavior of the users in the real time when they are there in the market and they are buying something. So at that particular point of time, if we can give them certain recommendations, or we can pass on certain messages or whatever offers which are available with us. So how to deal with the data that is growing at such a very fast pace? This is the another challenge for the businesses. Then we talk about the variety. As I said, in the old data, you can say the previously the data that was available in the tabular form only, right? Now we have huge variety of data. Data is available in the unstructured form and the semi-structured form, and 90% of the data is unstructured data, and this data is coming from the social media applications. And besides that, we have the web browsing data, weather satellites, IoT devices. We are talking about everywhere. We have the we are talking about the smart world, smart homes, right? Smart devices. We have smart refrigerators, we have smart TVs. So when we are adding this term of smart to all these devices, all the gadgets, that means we are talking about the data only. Data is being generated tremendously by all these devices. Then transaction details of the customers. We have archives, we have log data that is being generated at the back end. Then we have the databases, right? So we are talking about the cloud data centers. So huge amount of data, and the variety of data is being generated. So we have the all kinds of data these days, like on the social media, we see on the Facebook itself, we can upload the photos, we can upload the videos on the in YouTube, we have totally videos. In the Instagram, it is totally dependent upon the images. So how to handle all kinds of data? Then we're talking about the social networks, the graph data, right? So how does the and if we see the various applications we are using, so on the Facebook, you see we are getting the friend and recommendations. How come they are the Facebook is knowing they may be our friends? Right. So the kind of algorithms they are working on, and that too, they are providing the more or less the accurate recommendations towards. They are the applications which are recognizing our faces. How come they are doing that, and that too at a very fast pace? So you can say it looks like a magical world where the things are happening at a very fast pace because of the advancement in the technologies. Then we have the next way that talks about the veracity. That is the certainty of the data. We say internet is the most unreliable source of information because whatever you are uploading, whether you write a tweet, whether you write a Facebook post, and whether you write a reviews, nothing is being checked. So there is no check on this particular data. Then how to use this particular data? How can we trust on this kind of data and take the business decisions where you can say where a large amount of finances are at our stake? So how to handle this kind of data when we're talking about the trustworthiness of the data? Study says 3.1, see $3.1 trillion is the estimated amount of money that is spent on the poor data quality in the US economy every year. So lot of investment is there in order to process this particular data so that we can find out the good quality data, and then we can take the business decisions for you can obviously the ultimate goal is to make money or to make the profits. Then we talk about after understanding the various you can say, so what is how to understand this particular data. So according to the Gartner, big data is a high volume, velocity, and variety. So these are the three prime V's which are used to define the data. They are the information assets that demand high cost effective, innovative forms of information processing for enhanced insights and the decision making. So now, see, since we have large amount of data, companies are spending huge amount on storing this particular data. So how to make money out of this particular data, how to utilize this particular data. So in order to derive some useful insights for better decision making, we need to process this particular data, because storing this data and processing it requires huge investments. So according to the Gartner's vice president, information is the oil of the 21st century and analytics is the combustion engine. So it is important that we analyze the data that we have stored and derive some useful insights so that we can make more money out of it. And based on that, so what is the data analytics that we are talking about? So because we have large amount of data, and data is considered to be the new enterprise currency. That means if you have data, you are the richest person in this particular world. So what is big data analytics? It is the process of collecting, examining, analyzing large amounts of data to discover market trends, insights, and patterns that can help companies make better decisions. So better business decision is the ultimate goal for the big data analytics. So depending upon the goals of the business, so we have all these the kind of analytics that can be done. They are you can say they are categorized into different types. So let us understand what are the various types of big data analytics. Descriptive analytics, it tells us how you can say the descriptive analytics is used to answer what has happened. We have huge amount of historical data, right? So that can be used to understand what were the trends, right? And based on, see, the descriptive analytics is being done by the companies in order to get the updated information. So when we see the data of the last 1 year, what has happened, we can understand, right? So this is you can say this particular kind of descriptive analytics. Let us say a company who is involved in the gaming, right? So they come to know in the past 1 year, or you can say in the last few years, when they see the trend, the data, so they see that for a particular duration, let us say during the month of June, right? They see there is increase in the sales of the devices which are used to play the games. So what has happened, right? So they observed there was a spike in the increase in the devices related to the games during the month of June, as well as in the month of October, or let us say the September, October to November. So this is the descriptive analytics that is being done by the company. That is what has happened. Then diagnostic analytics. Diagnostic analytics is being done in order to develop the reasoning behind what has happened. That means we try to answer why it has happened. why there was a spike in the devices related to the games of the teenagers during the month of June or during the months of September, October, November. So there is a reasoning that is being developed for developing the, so here we answer why it has happened. Diagnosis is being done. So let us say like when we go to a doctor and we say these are the symptoms, that is what we have felt. So doctor recommends certain tests in order to diagnose what was the reason for developing such kind of symptoms. So the doctor is also trying to identify why it has happened. So we identified the reason behind the increase in the sales of the devices related to these online games, or maybe let us say the PlayStations which are there, or some accessories related to that. So in that case, we say, let us say, because it was June, it was you can say the holiday time for the teenagers or for the all the children. So they were buying these items. And during the month of October, November, December, because it is the festival time, right? So these are also used for the gifting purpose. So this is how the reasoning is being developed, why something has happened, and this is the diagnostic analytics. Then predictive analytics. So predictive analytics, we try to find out what may happen in the future. Since we saw the trends during these months, the sales were increasing for all these devices. So what may happen in the future? So that is called as predictive analytics. So that means there is a probability that during that particular season, again, there may be the increase in the sales during the month of June or during the months of September, October, and December, uh, and November. So what we can plan for it, right? So this is predictive analytics. Then prescriptive analytics. So we know. So what may happen in the future? There is a probability that the trend may follow in the future. Then prescriptive, doctor prescribes you after identifying what has happened, after doing the diagnosis. Prescriptive, the doctor gives you the prescription that you take these medicines, right? So that you are able to recover. Then here in the business, what is prescriptive? That means what action should be taken, what is prescribed. So if there was a trend that we have observed, and this we have also identified the reasoning behind that, so we prescribe that during that particular period we should align our marketing campaigns accordingly, and you may be getting the messages accordingly during the, like during the vacations we get mostly messages related to the you can say you may go plan your vacations to certain places, right? So accordingly these marketing campaigns are being designed, so based on the reasoning that we have developed, right? So prescriptive analytics answers what action should be taken. And these days we also talk about uh, cognitive analytics. Cognitive analytics understand the behavior. So the mostly used in, like we are getting the calls every day from the call centers. Understand, apply the artificial intelligence techniques on these call records, the voices, the interactions that have been recorded, and identify the various patterns in these interactions, and we can find out certain you can say do certain analytics, so that we can also derive certain business values out of it, and we can improve the you can say the working of the call centers. So that is the highest level that we say these days we are talking about the cognitive analytics by applying the artificial intelligence techniques. So these are the various kinds of analytics that are being studied, and these are being done by the businesses in order to improve their business. And there we say this is all dependent upon the data. So let us see just, can you please answer which of these is not a characteristics of the big data? Please write your answers in the chat box. 75 participants are there, so at least 50 may answer. Yes, please. Which of these is not a characteristics of the big data? Please keep writing. Thank you so much. I'm getting the 100% correct answers from the all, and thanks. And I'm really thankful for thankful to all of you who have been listening very actively. Thank you so much. Okay, let's move ahead. Since we have discussed about the analytics, now let us understand. Like we come across the terms data analytics and the term that is the data science. So, can anybody tell me what is data science? Yes, please. Please unmute and you please share your opinion, whatever you know about it. What is data science? Yes, please. I'm eagerly waiting for the answer. What is data science? Please unmute. Otherwise, I'll have to call up somebody's name. Yes, please. What is data science? Okay. Is it statistics?
No.
There are some answer in chat.
Okay. Let me. So that's why I was just wanted कि कोई जो है मुझे. Okay, data science is the study to extract meaningful insight from business remote data. So it's a copied answer somehow. I don't know, Google helped it out. Yes, statistics plus machine learning. Great.
To extract
Okay.
information from the data.
Yeah.
To extract information from the data.
Yeah, to extract information from the data. Yes. Okay, let me do one thing. It will be easy for move to the new tab. So I'll be able to see the things. Right. So, okay. Let me. Okay, let us understand this way. So that's fine. Most of you have written the correct answers only. So we have data, right? When we integrate, or you can say when we apply maths to this data. So we know we have so many techniques, so many methods in the mathematics. So that since mathematics is a generic term that is being used, so I've used mathematics. Applying mathematics on the data to get the insights, and technology is the deriving force over there. So here we say data science is the science of applying the mathematics to the data for generating the useful insights with the help of the technology. So without the technology, we cannot do anything, right? So we say that when you can say it is like the mathematicians who are learning the you can say learning the computer technologies, or you can say the computer science algorithms or the methods, or the computer scientists, they are learning the mathematics, or you can say they are joining the hands together, right? And that is what is we call you can say this is the integration or the application or amalgamation, whatever you can, whatever terminology you can use. So I thought because since the mathematics community is there, I tried to create one equation for the same. So when we apply the mathematics on the data with the help of, and you can say it is catalyzed, right? So the catalyst is the technology to drive the insights for the business so that we can again make the important decisions and drive the value out of it. And here you see what is data science. Data science is basically the multidisciplinary field. And you see the two main disciplines are the statistics and the computer science. right? So in these two, you can say at the common point between, you can say, in between is the data mining. So data mining is basically a process which involves the various methodologies, you can say, where we have the artificial intelligence techniques, then we are doing the predictive modeling, we are using the databases, then the statistics. Again, see, we do the predictive modeling by applying the statistical techniques. Then when we are talking about the databases, we are talking about everything related to the databases. That may be the storage, that may be management, that may be related to the structured data, unstructured data, or semi-structured data. So that's where we are, the term being big data is being used over here. Then we are talking about the artificial intelligence techniques, since machine learning is kind of a artificial intelligence technique, and deep learning is a kind of you can say machine learning techniques, where we do the you can say the feature engineering part is done automatically without the interference of the human beings. So data science is not a single domain. It is basically the interdisciplinary field where so many other disciplines are being integrated in order to derive the business values. And predictive analytics, it is called as this is basically the application of the data science. So here we say, when we are talking about data science, so many fields are involved into it. So earlier we say the data analyst and the data scientist, they used to be considered as the different persons, but now these days data analyst and data science, these terms are being used interchangeably, and their roles are more or less merging. So they are going to do the similar kind of tasks. So earlier the data analysts, they were doing only the you can say the analytics part only. So they were not doing any technical parts, you can say the applying the algorithms. But the data science people used to build the models, they used to apply the machine learning or the deep learning algorithms. But these days we say the data scientists and the data analysis, they are doing the more or less a similar kind of tasks. So here you see, when we see the data science timeline, so we are talking about the neural networks. It's you can say in this particular age, in that's a 2023, and the neural networks, they were designed in 1943. So how many years we can say? It's more than 70 years old, this particular these neural networks, which is the core of deep learning, they were designed. And the future of data analysis, see, Turkey talked about the future of data analysis in 1962, and they were talking about in this particular the relational databases and exploratory data analysis again in the 1977. So these terms had been they were there in that particular period also, and they were talking about, and now it's not going to be just statistics. The term statistics should be replaced with the term data science, or they may be used interchangeably, because it is most of the statistics, they are being used in the field of data science. So then you can say from data mining to knowledge discovery in the data mining, like so many terms they came up and creating a lot of confusion, right? So because we were not clear what we are talking about, data mining is just one step in the knowledge discovery in the databases. And there also we were talking about identifying the various patterns, taking out the insights for the better decision making. And there was no looking back. Here you can see in the Wu in 1997 talked about the statistics is equal to data science. So there were so many publications and so many developments that have been going. And in order to handle the big data, there was a MapReduce and Hadoop, and so many other technologies have been derived. And here you see the AlphaGo, by DeepMind. Here you can say, since the you can say the algorithms which were developed for playing these games, they were the masters, they were losing the masters were losing to their self-created games during that particular period, and that's going on. And nowadays in 2018 we were talking about the graph technologies rising. Then the Python became the you can say the most prominent programming language for all kinds of applications. So the data science has had its birth in 1943, way back 70 years old. Since due to the revolution of the World Wide Web, we started talking about large amount of data in the last few years, maybe last 5 to 10 years only. So the neural networks became popular with the deep learning algorithms. And here you see this is the complete data science process. And the first important task in the data science process is it begins with the business understanding. So what is the problem that we want to solve? So are we looking for something related to the market segmentation, or we are trying to find out where to launch the product? Are we looking forward to what all features should be incorporated in our new products? So looking at the trends, we can find out whether the what kind of features are being liked by a particular group of audience for a particular type of products. So because these days everybody is buying the smartphones, so in all these smartphones, again, what are the features which are being liked? So some people prefer buying a mobile phone which is having the good quality camera. Another may be looking for the good quality audio. Another may be looking for the mobile phones which are more stable. They don't hang and they have a long life. So depending upon the so we have to understand the business first. So what is the problem that we try to understand? Then comes the next step of data acquisition and understanding. So how to acquire the data, because we have different kinds of data. The data sources may be on the premises, they may be cloud databases, they may be the files. Then how to create this data pipeline, how to pre-process the data. Then what kind of environment it is, whether it is a local environment or it is in the cloud environment. Then for exploration and the cleaning of the data, we have to understand, because we have to use the techniques for processing the data. That means the pre-processing of the data, for the cleaning and understanding that particular data, we have to change the technologies, right? So we have to change the methodologies if the data is structured or semi-structured or unstructured. So accordingly, we will be using the techniques for data acquisition and understanding. Then next comes the modeling, how to model the data, how to develop the predictive models. So we are doing we have seen we can do the prescriptive modeling, we can do the predictive modeling, descriptive modeling, right? So different kinds of analytics are there. So depending upon the requirement, we have to see what kind of model we want to develop. Then how to develop this particular model. So the feature engineering and the training, validation and evaluation, these are the important features for creating the models. For creating the models, we use the various machine learning or the deep learning algorithms. So in the feature engineering itself, we have a complete study, like how to you can say how to we have large amount of missing data these days, how to impute, how to handle this missing data. Then we do the encoding, we have a temporal type data, text, image, feature selection. So depending upon the kind of data we have to use the different feature engineering tasks, right? Then how to train this particular data. So we have, is it available on the cloud? Then we have to use the cloud algorithms or the ensembles, or then how to validate this particular data. We have the cross validation techniques and so many other techniques which are available. Then how to do the parameter tuning, then how to evaluate, how to assess the performance. So we cannot use any model in any kind of real environment without assessing the performance of this particular model. So after following all these steps, the model is sent for deployment. Deployment means making it available in the real environment so that we can have the acceptance from the customers. So again, for the development deployment, we have to see how it will be deployed, whether it will be deployed as a web service, or it will be in the form of the dashboards, reports, charts, or any other intelligent applications which are there. Then after deploying, again, the another task is there as of monitoring. So let us say, like we see how if you have seen monitoring, if you want to see the performance of your computer, so you have a dashboard, you can access it and you see the number of applications which are being running in your system and how they are performing. What is the performance of your system? You can see that by monitoring the window that is there. It is available to you, right? So you see when someone is admitted in the ICU, so there are so many devices attached. We have a monitor which is there to monitor the health of the patient, right? So you see so many lines, so many signals, right? So that is the heartbeat. We see on the basis of that, the doctors are monitoring the performance, right? So all these are the tasks which are being done after the deployment only. So it is very important to check how valid is this particular model and what is the accuracy of this particular model. During the COVID, we were not provided the vaccines unless they were tested properly. So the testing is also being done in the different phases, first on the softwares, or you can say, and then in the real time. Humans were not given the vaccines because they were not given to all the humans. They were not distributed in the public before they were tested on the few humans only, right? So they were the test cases over there. Once they found out it worked over there, only then it was distributed in the public. So there are so many things for every domain that we say. The testing also plays a very important part. So this is the complete data science process where we say we are using all kinds of techniques, whether they are the machine learning algorithms or the deep learning algorithms, where the processing does different kinds of analytics, and they start from the business understanding of the problem. And here you see how the model is developed. So what we have after the data acquisition, we have the data, and this data, from this particular data, we take the training data set and we apply the algorithms. And depending upon whether it is an unsupervised learning algorithm or the supervised learning algorithm, right? So after applying that particular algorithm, that we check whether this particular data, see, the testing is being done on the test data set only, right? Because if we pass on a medicine in the public without testing it, without understanding what are the effects, whether it is working 100% accurately. So let us say if you develop a model and you say that this is used for predicting the whether the person is suffering from a particular disease or not. So in both the cases, it is very few. If your software that you have developed or your expert system you have developed, if it predicts that a person is suffering from the cancer, but a person was not suffering, that's very dangerous, right? And the vice versa also. So the false predictions, right? They play a very critical role when we are talking about something that is related to the life of a human beings, or where the large number of finances are involved. You predict that you can buy a particular stock, but that prediction was not correct. So a person may incur lots of losses. So when we are talking about large amount of, you can say, the big business decisions, we have to test the accuracy first and the validity of the model, how well it is this model in a particular environment. So this is how, this is just a brief of what I explained, that how these models work. Then who is a data scientist?
Are you there?
Yeah, I'm here. Okay, shall I start?
Yes, all the participants, ma'am is back to the session here. So we are starting the lecture, reconnecting it. Kindly join. Thank you, ma'am.
So we were just trying to understand who is the data scientist, and various researchers have given their own definitions, although there
Professor
is...
Shikha, you have to present it again.
Okay, it's not visible. Okay, let me... Ma'am, is it visible now?
No. It had started, but I don't know.
No, ma'am.
Okay.
Now it's visible.
Okay. It's fine now?
Yes, ma'am.
Okay. So we were discussing about who is a data scientist. So different researchers, they have given their own definitions, or there is no single definition for the data scientist. So I hope you understand what they are trying to convey. So according to the Josh Wills, data scientist and engineer, a person who is better at statistics than any software engineering, and better at software engineering than any statistician, right? So as I said, data scientist nobody can define. Then in another definition, they say that data scientist is a unicorn that bridges maths, algorithms, experimental design, engineering, communication and management skills, but they aren't specialists in every aspect. That means they can have any knowledge of any of these domains or of all the domains, but they need not be the specialist. That means they need not carry the responsibility of doing anything completely into this. But they know maybe some of these, or they may know all of these. So it's very difficult to define who is a data scientist. Accordingly, like what I learned from the various studies is, data scientist is a person who is able to transform a human problem into the computer problem. It's like when we studied about the process of the data science, we were talking about the business understanding. So like when we are talking about the business, so the person who is handling the business, it's not important for him to be a technologist or understand the technology. He only knows that he wants to increase the sales of a particular product. And now whatever you do with the data we have, so you tell me what all algorithms or what all techniques or what all business strategies he should take up so that he is able to increase the business. So it is the role of the data scientist to understand the human problem, whatever it is, and then convert it into a computer problem. So, or we can say that a data scientist is a person who understands the principles of the multiple domains and is able to apply the principles of one domain into the another domain. Let us say a person, data science may be a person who understands the mathematics, and he can explain how these mathematical principles can be applied for solving some real world problem, and he will be able to make the others understand these principles in a simple English language, because the people will not understand the language of mathematics. So this is how we try to understand what is the role of a data scientist, or what kind of task he is or she is performing. So another question for you: which of these analytics answers why it happened? So we discussed the various kinds of data analytics techniques: prescriptive, diagnostic, predictive, and descriptives. Please write your answers in the chat box. Yes, please. Which of these analytics, why it happened? More answers, please. Just 3 answers I got. Please carry on. Please use your wisdom, not Google's wisdom. Yes, please. More people, please. Don't take much time. Yes, please. Okay, I'll wait for a few more answers, then I'll proceed. Yes, please. At least 2, 3 more answers. Two, three more answers, please. Okay. The slides are visible?
Yes, ma'am.
Okay. So this time I got the mixed answers, but the correct answer is, it is diagnostic. So doctor tells you to go through certain tests so that he's able to develop the reasoning why you suffered from certain symptoms. So why it happened is the kind of analytics that we do is diagnostic analytics. It's not the predictive or the descriptive. So moving ahead, okay, let's skip this. So the various data science applications where you can say all these techniques are being used. So here you can say this is just a glimpse of the various applications of the data science. Like here you can say in the marketing, it is being used for predicting the lifetime value of a customer. If we already know there is a probability that this particular customer may switch over, we can offer to do something out of it, right? So and then which product should be we should sell along with another product, that is cross selling and upselling. Then we have social media, the sentiment analysis, the digital marketing. The digital marketing is the one of the highly paid job these days, because whatever you talk about, we are talking about almost 5 billion users are there on the social media. Then we are talking about the travel, like checking out on the dynamic pricing, predicting the flight delays. Then in the healthcare, disease prediction, medication effectiveness. Then in the sales, discount offerings, when we should offer the discounts, as we discussed during the month of June. So before that, we can provide certain offers for the vacations, for the various items which which are being purchased for the during that particular, depending upon the trends. Then we can use data science for demand forecasting. Like when we have the festivals, it is quite natural that the product demand increases. But what kind of products are in more demand during a particular, you can say during the particular part of the year. Similarly, when we're talking about the automation, self-driving cars. In the self-driving cars, prescriptive analytics is being done. So then these are the automated systems. It checks out what is happening and appropriate action has to be taken, because because whenever we see the environment is very dynamic. When we are on the road, we have to take the immediate decisions whether we have to put on the brakes or we have to change the side depending upon the condition of the road. So the self-driving cars, they are doing the prescriptive analytics based on what is happening around them. Similar cases with the pilotless aircrafts or the drones. Then we have the credit and the insurance for the claims prediction, then the risk detection. So these are the few common applications that we are discussing, which are there for where we are using the data science. Because for every domain you talk about in every business, data is available, and that is available in the large amount. So now let us discuss one application of the data science in detail, that is the recommendation systems. So we all are getting the recommendations. We all see that when we are shopping online, whether it is Amazon, or you can say when you are watching the videos or you are listening to the music, everywhere where we are getting the recommendations. You are getting the friend recommendations on the Facebook. You are getting the product recommendations in the e-commerce web portals, right? So how these recommendations are being generated. So let us understand, and at what stage where we are using the mathematics for these applications. So when you say we all are watching the Netflix, can you tell me where you have seen the recommendations in the Netflix or the Prime Video? Anybody? Anybody? If you have seen, I know, I'm sure that we all watch Netflix and the Prime Videos. So there you see that you get the recommendations that the people who watch these kind of movies, they also watch this. So you get a watch list for yourselves. That is the set of recommendations which are being provided to you. So these recommendation systems, they became popular when in 2009, Netflix declared around $1 billion prize just to you can say designs any algorithms which can improve the recommendation system accuracy of these recommendation systems just by few percentage. And that time it became very popular. So the people started getting into developing the recommendation systems for all kind of applications. So it is like customers who bought this particular items, they also bought this, right? When you're buying the books, you get a list of recommendation for the books. When you're buying let us say the other products or any kind of products, so you get the set of recommendations for this. So like in the Amazon, Netflix, Pandora, all kinds of e-commerce, or so we are getting the recommendations for everything, whether it is a product or it is a service. So what is the goal? Predict user preferences given some prior information on user behavior. That means whatever activities we are doing, whether it is a shopping or we are just surfing the net, all activities are being tracked. So you can say you are all the time under surveillance. You must have known this, all the applications, all the mobile applications we download. So recently, it was only recently that the government made it ensured that these applications have to take your permission to track your activities. Otherwise, all these applications, they were tracking your behavior, all the activities you are doing on your mobile phones, you were being tracked without your permission. So a lot of data, your private data, was going without you knowing anything. So we can have product recommendations, we can have content recommendations, we can have entertain recommendations, and there is a long list of kind of recommendations depending upon the kind of applications we are talking about. So how these recommendations are being generated? So just taking an example of the rating matrix. So we see when we are buying the products, we look at the ratings. If the ratings are high for a particular product, we will go for it. If the ratings are low, we don't go for it. So depending upon the user's behavior, so they may have the different kinds of rating behavior also. So what is being done, these ratings are being analyzed, right? So ratings for the few items by the users, and they are fed into the recommendation engine, and then we predict, the system predicts what rating will be provided by this new user to this new product. If the rating is in the range of my range, maybe the more than the average rating that I give to the various products, then this particular new item will be recommended to this particular user. So let us just have the various kinds of algorithms which are being used for developing the recommendation engines. They are categorized as the collaborative filtering algorithms, or the content-based filtering, or the association analysis. The collaborative filtering, they are basically used based on the behavior of the users, my community, my neighborhood. So it is a neighborhood method. So the system, the recommendation engine, it finds out what the other similar people are doing, right? What is the behavior of other people? Like if I had purchased, let us say, these 5 items, so it will find out all the other similar users, and then on the basis of that, it is going to predict what I will buy. So this collaborative filtering again is based on the user based or the item based. Then we have the content based filtering, where what I am buying, my user profile will be analyzed, and then based on that, what I have been buying in the past, then based on that is the recommendations will be provided. So let us take few examples and understand these different types of algorithms. So let us say in the collaborative filtering, so let us say the actions. So the first person watched the movies of the genre action, right? So the action, genre was the action. Another user was also buying such kind of movies. So there was a similarity because both of them are watching the movies, action movies. So if the new movies was watched by her, then this new movie will be recommended to this user because they were showing the similar kind of behavior. So this is called collaborative filtering. Then let us say we have, when we talk about the content based filtering, so we talk about a person was watching the movies that belong to the comedy genre. Then there was new movie in the, let us say there was new movie in the Netflix. So this new movie that belonged to this particular comedy genre, that was recommended to us. So here it was the content that was used to find out the similarity, and in the collaborative it was based on the users, that the similarity, user behavior, that the similarity was found. Then in the collaborative filtering, again we have the user based collaborative filtering and the item-based collaborative filtering. So again, when we are talking about the user-based collaborative filtering, here you say we have two users. One user, he ordered like a pizza and some salad, and the another user who had also ordered the similar kind of products. Then the first user, since he had ordered the drinks, so this, because they were buying the similar kind of products, so there was a similarity. So this new drink, that was ordered by the first user, that was recommended to the next user. So this is called user-based collaborative filtering. Then the item-based collaborative filtering. So in the item-based collaborative filtering, we say the person, he has purchased one soft drink. So when some other soft drink was available, so we say that the item was similar, right? So this new soft drink was recommended to the user. So this is how the recommendations are being generated. Then the question comes, how this similarity, see, everywhere we are talking about similar users, similar items, similar content, how this similar word is computed. So this similar word is computed using the mathematical formulas. So this is how, here you can say this is the complete system, how it is being filled. So we predict the user preferences based on the prior user's feedback. Where we say we gather the data, then we build a model based on the user item rating store. Here we are just taking into consideration the rating matrix, and then we generate the recommendations for the new user based on the various kinds of techniques which we have discussed. Then I said that the important part is, what does similar mean in this particular context? The similarity we compute using the various methods, like we can compute the Euclidean distance, or we can compute the cosine similarity or the Pearson correlation. So these are the mathematical functions which are being used for computing the similarity in the recommendation systems. Then let us take one example. So we take the example of a movie recommendation system, and let us say we have a matrix. So this is how the data is being stored. So this is the rating matrix. So these are the names of the persons who have watched all these movies. So these 5 movies we have taken, and these are the ratings. So Joseph rated the Godfather movie as 5 and the 2001 A Space Odyssey movie as 4. So these are the rating behaviors, the kind of ratings which are being given, right? So now our task. So what do we want to do? Our task is to find whether the user Olivia, so this particular Olivia will like the movie 2001 A Space Odyssey or not. So here liking means, say, if we have to predict the rating, what kind of rating it will be giving. So based on that, we will be assuming that she will like it or not. So this rating that we are going to predict based on the behavior of the other users, if it is a similar kind of rating that is being given by the Olivia to the other movies, or the more than the average, if the predicted rating is more than the average, then we assume that the Olivia will like this particular movie and it will be recommended to her. So the first step will be to find end users similar to the user Olivia who have already rated. So we are talking about collaborative filtering, where we are, again, the neighbors we are finding is user based. So we are performing the user based collaborative filtering over here. So first we have to find out the end users, right, which are showing the similar kind of behavior. And second step will be to compute the rating for the user Olivia from the cohort of the similar users. So how do we do that? So this is the data that we have, and we are going to perform this particular task. So the cosine similarity measure between two non-zero user vectors for the user Olivia and the user Amelia is given by. So this is a function for computing the cosine similarity, and we have the vectors. So all the information here you can see that. So putting the values of x and y. So x is, here you can say, the Olivia, and y is the Amelia. So we have the rating factors we have seen in the previous table. Here you can see we have the Olivia and we have the Amelia and we have the ratings. So if the Olivia has not rated any movie, it will be assumed as 0. So based on these two vectors, we are computing the cosine similarity, right? So it comes out to be 0.53. Then we use the centered cosine similarity or Pearson correlation between the ratings for the user Olivia and Amelia. So we are computing the centered cosine similarity over here. right? So we are computing the Pearson correlation. So we can use the different matrices for computing this. So after that, what do? We compute the normalized rating matrix, and this is how it comes up, and user to user similarity matrix. Here you see. So after computing the user to user similarity matrix, based on this, we compute the recommendations, and then we just provide those recommendations to the unknown user for any of the new products or any of the new services. So this is how these collaborative filtering systems, they work. So let us understand another problem. Let us say there is a burger chain who wants to open its delivery centers across the city. So there are large number of challenges to find out this. So they need to analyze the area from where the burgers are being ordered frequently. Then they need to understand how many burger stores has to be open to cover the delivery area in the area. They need to figure out the locations for the burger stores within all these areas in order to keep the distance between the store and the delivery points minimum. Then according to you, for resolving, we know that for resolving these challenges, we require a lot of analysis and the mathematics. Now, according to you, which particular algorithm or technique can be used to solve this particular problem? The problem is the burger chain wants to open its delivery centers across the city. So in which particular area the particular center should be opened? Anybody who can make up and understand this? Anyone? So here we are not talking about giving the recommendations. Here it is a business problem we are talking about. Here it is a business problem that we are talking about. Here it is not a recommendation system. It is another problem, right? So we are just talking about, we want to open a new delivery center. Right. So let us say there is no delivery center in the sector 128 campus or nearby. So the burger chain is looking forward to at which is the most appropriate location for opening the delivery center, so that it is able to cater a particular area. And let us say if it says that it will be providing a delivery within 30 minutes or 30 to 40 minutes, then which particular location should be the appropriate location? So how it is going to solve this particular problem? Anyone? So when you see, let us say we are talking about the burger chain. So when you are giving any orders on any of these applications, whether it is Swiggy or Zomato, then what kind of information, what kind of user information is stored over there? Yes, please. What kind of information is being stored over there? When you place any orders, we all are placing the orders. No, user information. Delivery time is fine. They have to specify. That's why we are looking forward to, we have to find out the appropriate delivery center. But when you, let us say you register over there. So what kind of information you are giving on the Zomato or the Swiggy? So first time you have to register on these applications, right? See, the description of items when you are placing the order. So you have to give the location, you have to give your exact address, you have to give your mobile phones. So the important part is the delivery address, right? So that should be correct, so that you are able to get the orders on time. So now if we say how to resolve this particular problem, since you know how many orders are being placed on the Zomato or Swiggy or any other applications for any food delivery applications. So they have large amount of data, right? So they will find out what they are going to do is, they will, let us say they have identified they have to take the orders in the 128 or 132 or nearby this particular area they have identified. So they will use the data of this particular location in order to identify the centers. So what they can do, so they will just solve this problem using the clustering. So that is the data clustering algorithms. So what they have is, they have large amount of data about the users. They will apply the clustering algorithm and find out the clusters, right? So when we have the information about the location, we'll be getting the different clusters on the basis of the locations, and they will also find out the frequency of orders they are getting the users from a particular location. And when we apply the clustering algorithm, so after getting this group of users and what is their frequency of placing the orders, so they will find out and how and what when we so when we are applying the clustering algorithm, we find out the centroid, the central point of this particular cluster. This center point of the cluster will be the location where this food chain should be opened. So this is one application that where we have to choose like which particular algorithm or which particular technique will be used for solving the real life problem. So what is clustering? Clustering is basically the grouping together of the similar data or similar users together, and the similarity between the users which are there within a cluster, that is highest, and the similarity between the users which are in the two different cluster, that has to be minimum. So here this particular thing is shown with the help of the different you can say different shapes. So all the shapes which are similar to each other, they are put into one cluster, and the shapes, and they are far apart, so we can see the difference. So this is particularly in order to understand that when we are feeding the samples, we are finding the patterns, and similar patterns are stored together into the one cluster. So this kind of clustering algorithms can be used to solve the problem as we have discussed. And do we have time? Yeah, Amita? So, okay, let us take up, see this, I'm taking up a simple k-means clustering algorithm, which is one of the oldest algorithm that was designed in 1979. And this is the first algorithm that is being used very widely everywhere for the various kinds of applications. So here, you can say what we have a set of n distinct objects, and it is a partition-based clustering algorithm where the partition is nothing but a cluster or a group. And the partitions are created such that intra-cluster similarity is high, but inter-cluster similarity is low. And the user here, you can say this is also a limitation of the k-means clustering, that you have to specify the value of k. K is the number of clusters that you want to create. So if you are not aware of the number of clusters, we have other clustering algorithms which you can use, or we have the methods to find out what is the appropriate number of clusters that should be created based on the data that we have. So what do we do to begin with in this particular algorithm? So what we have input the data set that has n objects, and k is the number of clusters, and the output is the set of clusters. Right? So we randomly choose k objects from the D as the initial cluster centroids. And after that, for each of the objects that is there in the D, we compute the distance. So here again, we are talking about computing the distance between current objects and the k cluster centroids, and then assign the current object to that particular cluster which is the closest. So everywhere, see, we are using the mathematics only. We are using these mathematical formulas to compute the similarity. So these are the L1 norm, L2 norm, or L3 norm. So the different kinds of norms that we are using in order to compute the distance or compute the similarity. And then we compute the cluster centers. So this cluster center basically is going to represent the exact location where we are going to open the you can say, let us say the burger shop, or the burger outlet, or any other outlet in the particular area. And we repeat all these steps. Excuse me. And we repeat these steps until the stopping criteria is satisfied. So let us take one numerical example. So here you can see these are the norms and the distance measures, like the cosine similarity, Euclidean distance, and the Manhattan distance, which you are already aware. So let us say we have the data. So for the sake of simplicity, I've just taken the two attributes. So these attributes are nothing but the features. Like features in the example that we were discussing, we were talking about the location of the users or the frequency of placing the orders. So you can have n number of details. So what do we do when we apply the k-means clustering algorithm? We have just plotted the data in the here. So here we have at the x-axis, we have the A1 attribute, and on the y-axis, we have A2 attributes. So after plotting these points, what we are doing, we are randomly choosing the three locations, three centroids, because initially we don't have any information. So we choose any three any three, you can say, data points to be the centroids. And after choosing these centroids, let us say C1, C2, and C3, because we wanted to create three clusters. So we have chosen the three centroids from this particular data, and these are the attribute values of these centroids. So now we are going to use a Euclidean distance measure, that is an L2 norm, as a distance measure. So what we are going to do, we are going to compute the distance of all the data points which are given in this particular data with all these three centroids. So here you can say this is the distance matrix. So we have A1 first attribute, second attribute, D1 is the distance of this particular data from the cluster 1, D2 is the distance of this particular data point from the cluster 2, and D3 is the distance of this data point from the cluster 3, and accordingly we have shown the complete distance calculation. And here you see the cluster number that is assigned to first data is 2, because we see we are computing the distance. So distance means lesser is better. So here you can say 4, 1.4, and 5.9. Since 1.1 is the minimum distance of this data point to the cluster 2, so this data point is assigned the cluster number 2. So similarly, we have assigned the various clusters to these data points. So accordingly, here you can see in this particular plot, so the cluster 1, C1, C2, and C3 have been identified. So cluster C3 has only 3 data points, cluster C2 has 4 data points, and cluster C1 has some maximum data points. But since in the initial centroids, they were chosen randomly, we cannot say that these are the correct clusters. So what do? We repeat the process. We first compute the centroids, and after computing, see, how do we compute the centroids? Now the new centroids are computing by taking the mean of all the data points which were there in C3, C2, and C1. So we get the new centroids. So new centroids for C1, C2, and C3 are here, and these are nothing. These are the mean values of all the data points for attribute 1. So we will take the attribute values of A1 from all the 3 data points and compute the mean, and finally we get 4.6 and 7.2. So these are the new data points. And see here, new in k-means clustering algorithms, you can say that new data points or new cluster centers, they are not the actual data points, but they are the virtual data points in the k-means clustering algorithms. So now again we follow the same process. We next again reassign the 16 objects which were there to these 3 clusters, and we keep on repeating this particular process. And finally, to cluster centers, after the second iteration, we again do that. So final clusters, after the second iteration, we are able to get these data points. So we keep on repeating this process until there is no shifting of the data points from one cluster to another cluster. So this is how we you can say find out the various clusters, and then these are the cluster centers, or you can say these are the appropriate locations where we should open the outlet. So similarly, we can apply this to, you can say, when we are doing the marketing. So the market segmentation is another application where the complete market is segmented into the various clusters in order to identify the set of users with a similar likings, so that a particular you can say particular product may be launched only to this target audience, not to the whole community, which may not be converted or which may not buy a particular product. So this is how you can say the various organizations are using the data science for solving their business problems. And here you see we have the various Python libraries for the data science like NumPy. So these are the basic Python libraries which are being used for you can say for the implementation of all these algorithms, or for developing such kind of applications like NumPy, then we have SciPy, then Pandas, then Matplotlib, and the TensorFlow. So if we have time, I think we don't have time, otherwise I could have covered the clustering using k-means in the Python. And since we are running short of the time, I'm done for the day. Thank you so much for your patience. These are the references. And if you have any queries, you may ask. Thank you so much. Any queries?
Any questions from the audience? And I guess no questions from the audience. Shikha ma'am, I guess no questions from the audience,
Okay,
though it was
okay,
a
fine.
very interactive and very informative session. Even everybody is writing in the chat box regarding your lecture.
Yeah, thank you so much.
Yeah, all were tied to their seats during the lectures. I guess all have been benefited by the knowledge shared by the ma'am regarding the data science and its algorithms. So we hope to learn more from the Shikha ma'am in our upcoming events. Thank you, ma'am. Thank you,
Thank you.
Alka Tripathi ma'am.
Thank you, ma'am. Thank you so much.
Thank you, everyone, for being a part of this session. Thank you.
Thank you.
Thank you, ma'am.
Recording of